All right, so today we're going to start to learn how to use different operations with our radicals. So addition, subtraction, multiplication, division. With that, we have to make sure that we're solid on reducing radicals, which is what we did yesterday. So since we struggled with that, we're going to spend some extra time doing that today. That's probably, we'll get through multiplication, division. That's all including reducing. We won't get to addition, subtraction today. That'll be tomorrow. Okay? All right, so turn the page. All right, so in order for us to multiply radicals, you have to make sure that you have the same index. Do you guys remember what the index is? Yes, that little number, right? Okay, so you have to have the same index when we're multiplying radicals. When you multiply the radicals, essentially what you're doing is you're multiplying the radicand. Who remembers where the radicand is located? Inside the radical, good. Okay, so if you have the same index, you can multiply those radicands. So the nth root of a times the nth root of b, the nth root of ab. We're good with that? Okay, so let's look at one now. Square root of 2 times square root of 8. What's it equal to? Square root of 16, good. Oh, hello, that's odd. What's the square root of 16? And 4 negative 4, okay? So it's plus and minus 4. So in your book, in tab 3, if you're using your calculator, your plus and minus is there. So it's plus and minus 4. Okay, always positive and negative. And the book is next to the math template key. If you hit the 3, it'll bring you to tab 3, which is where you'll find all your symbols. Okay, good. Any problems with that multiplication piece? It's pretty simple, right? Okay, so let's go to the next page. Oh. Okay, square root of 3 times square root of 12, what's it equal? Square root of 36. Why does it keep bouncing around on me? What's the square root of 36? Good. Plus and minus 6. Excellent. No problems with that, right? Okay, let's get a little bit harder. Cube root of 3 times the cube root of 9. Cube root of 3 times the cube root of 9. Cube root of negative 27. Good. Okay, how did I get that? Control caret. Yep. Okay. What's the cube root of a positive 27? 3. So what's the cube root of a negative 27? Negative 3. Now, normally, can we take the square root of a negative? No. Okay, so let's talk about this for a minute. Okay, so let's work on this one here. The 4th root of 4 times the 4th root of negative 4. Do the multiplication. What do you get? The 4th root of negative 16. Okay, so we just talked about this. Can we do that? We can take the 4th root of a negative 16? No, absolutely not. Okay, even index, you cannot have a negative underneath the radical. Odd index, you can. So can I do this? No, and we're going to talk about this in a couple of classes. This is actually an imaginary number, so we'll talk about that a little bit later on. We're not going to do it right now, okay? You guys ready? Okay, next page. Leave it. Okay, so we have to make sure that we can reduce radicals. So what this comes down to is paying attention to the index and figuring out how you can split up these numbers so that they reduce, okay? So if I'm looking at the square root of 72x cubed, I've got that 72, right? How can I break down 72 using one of my perfect squares? Remember, you want it to be the biggest perfect square possible. What? Okay, if I use 9 and 8, I'm going to have to reduce again. You want the biggest perfect square that divides into 72. 36. 36 and what? 2. So we're going to break down 72 to 36 and 2. All right, now we need to look at that x cubed. Remember, our rule is you want the index to divide evenly into the power. What's my index if nothing's written? 2. Here's that index, right? It's not, if it's not written, it's assumed it's 2 squared, right? Square root. Okay, so I want my 2, my index, to divide evenly into my power. Right now my power is a 3. Does it divide unevenly? No, so I have to split up that x cubed so that it will. How am I going to do that? I want mathematically correct words. Say x squared and x. Okay, because you want those, when you multiply this back through, x squared times x gives you what? X cubed. So those exponents always have to add back up, 2 plus 1, to be what it was originally, 3. That's how we're splitting it. All right? So now let's take the next step. Let's reduce what we can. Square root of 36. And thank you. Plus and minus 6. Square root of 2. Can't do it. Square root of x squared. X. Good. Square root of x. Can't do it. So what do I do with what's left over? Put them back together and put it at the end. Okay, your coefficient goes out front, your radical always at the end. Not so bad, right? You got to take it one piece at a time. Okay. Okay. I've got the cube root of 80 n to the 5th. Now, what column am I using up there? My square roots or my cube roots? Cube. So what's the biggest perfect cube that divides into 80? 8. So we're going to break down 80 into what? 8 and 10. Now, if you lose that index as you're working, if you don't write it, it's wrong. Make sure that you write it every single time. Okay. I've got that end of the 5th. Does my index divide in? No. So I need the largest number that's less than 5 that my index will divide into. 3. So we're going to use n cubed and n squared. Good. Why n squared? What's the reason? Good. Those exponents got to add back up to be 5, right? Good. We getting the hang of it? What's cube root of 8? 2. Just a 2? Yes, because it's an odd index. It's either plus or minus, and in this case, it's plus. Okay, cube root of 10? Can't do it. Cube root of n cubed? N, good. And cube root of n squared? Can't do it. So we put back together what we didn't use. We get 2n cube roots of 10n squared. All right, so I want you to try C for me, and we'll go over it in a minute. All right, guys, tell me how you're going to break down square root of 50. 25 and 2. Do you need to break down the square root of x to the 4th? No, because that index already divides into the power. You don't have to split that apart. Okay, if you did, fine, you'll get the same answers. You're just making more work for yourself. Okay, so if it already divides in, then leave it alone. Okay, what's the square root of 25? Plus and minus 5. Square root of 2? Can't. Square root of x to the 4th? X squared. So these ones reduced, and what I'm left over with is square root of 2. So you should have plus and minus 5x squared times the square root of 2. How many of you got that right? Very nice. All right, go ahead and try the last one. Okay, tell me how you're breaking up 18. Great. How about x to the 4th? We don't need to, right? Square root of 9? Good. Square root of x to the 4th? That looks weird, doesn't it? X squared and square root of 2? It is what it is. Good. How many of you got it right? Are we doing better? Great. Okay. I had a feeling all this would help. All right, let's look on the next page. Let's get a little bit harder with multiplication, okay? Now, your rule is you multiply first, you reduce second. Okay, so as long as they have the index, you can multiply those radicands, right? So if we're looking at A, we're going to start by multiplying. Do we have the same index? Yeah, what's my index? 3. Great. Okay, so we're going to start by multiplying those radicands. 54 times 5. What is it? 270. Thank you. X squared times x cubed. Good. Y cubed times y to the 4th. 7th. Don't forget your index. I forgot it. I had to put it in there. Okay, so we've got the cube root of 270, x to the 5th, y to the 7th. So are we okay with multiplying? Okay. I multiplied my numbers, multiplied my variables, I added their exponents. All right, when we multiply variables, we add their exponents. Yes, honey? A different index? Would there ever be a problem where there was a different index? No, you can't multiply if they don't have the same index. Okay? All right, so we're dealing with perfect cubes. So you should be able to look at that list and very quickly tell me what is the largest perfect cube that divides into 270? 27. Done. That was quick, right? Okay. So how are you going to break down 270? Cube root of 27 and cube root of 10. Great. Okay. All right, now let's talk about x to the 5th. Does my index divide unevenly? No, which means I have to split it apart. Okay. How are you going to split apart x to the 5th? X cubed and x squared. Great. We okay with that? Those exponents always have to add back up to be what it was originally. That's why we're 3 and 2. Okay. All right, x to the y to the 7th. Good. Cube root of y to the 6th. Cube root of y to the 1st. Okay, so you're taking it one piece at a time. We ready? Cube root of 27. 3. Remember, cube root, it's plus or minus, not plus and minus. So is it plus or minus here? It's plus. Okay. Cube root of 10? Nope. Cube root of x cubed? X. Great. Cube root of x squared? Nope. Cube root of y to the 6th? Y squared. Good. Remember, you're dividing this index into the power, right? Cube root of y? Can't. So what do I do with my leftovers? Put them back together. Cube root of 10x squared y. So your answer is 3xy. Did I write 6? I didn't mean to, did I? I meant to write squared. Thank you. My bad. Okay. 3xy squared, cube root of 10x squared y. How are we doing? Better? Okay. You have to scroll up, honey. Go ahead and try B for me, and we'll go over it in a second. Okay, so let's start with multiplication. Tell me what you got when you multiplied together your radicals, please. 6 times radical 147. How many of you got that far? No problems, right? Awesome. Okay, so we have to start talking about reducing. This is square root, right? Perfect squares. What's the largest perfect square? Awesome. 49, 3. X to the 6. All right, I don't need to break that down, right? Because my index will automatically divide into that power. How about y squared? Yeah, we can leave that one too, right? All right, so now let's take that step in reducing. Square root of 49. Yeah, we're going to go with the principal root just for right now. Square root of 3. Leave it. Square root of x to the 6. X cubed. Good. Square root of x, square root of y squared is y. Do I leave it like that? Please don't. What's 6 times 7? 42. Bring this stuff over here, okay? You want your radical at the end. 42x cubed y, square root of 3. How many of you got it right? Nice job. Yeah. I'm sorry? No. With square roots, guys, you don't need to write the index. It's assumed it's 2. Okay? We doing okay? Better, right? I'm sorry? Control up, delete. All right, so let's talk a little bit about dividing. Okay? Same kind of idea. Just like with multiplication, we multiplied first and then we reduced. When we're dividing, we divide first and then we reduce. Okay? So always divide first if you have the option. Okay, again, you have to have the same index. If you don't have the same index, can you divide? No. Okay. So let's look at the first ones here. All right. Cube root of 32 divided by the cube root of 4, negative 4. We're going to divide. So what is 32 divided by negative 4? Why does it keep doing that? Yeah, so I've got the cube root of negative 8. Okay, great. Now what? What's the cube root of negative 8? What kind of 2? Can you take the cube root of a negative? Can you take the cube root of a negative? Can you take the cube root of a negative? Yes, because it's what kind of index? Odd. You could take the cube root of a negative, you could take the 5th root of a negative, you take the 7th root of a negative, you could take the 9th root of a negative. As long as that number is odd, you can take it. Is it plus and minus? No, it's just negative. Okay. Cube root of 8 is 2. You need to memorize those, please. Okay? Make sure you have those memorized, guys. You need to know your perfect cubes. Need to. All right, let's move down. So we're going to start with division, right? So we've got the cube root of, what's 162 divided by 3? Pick one, guys. Can't have two different answers for the same problem. Thank you. And x to the 5th divided by x squared? X cubed. Good. Am I done? It's reducible, isn't it? Okay, so I want you to think about 54. Is there a perfect cube that divides into 54? What? Perfect cube that divides into 54. Biggest one possible. 27. So 27 and what? Good. Oh, why is not playing nice with me today? Okay, so we've got the cube root of 27. The cube root of 2. Okay. What about that x cubed? Do I need to break it down? No. Okay, so we've got that. Broke it all apart. What's cube root of 27? 3. What's cube root of 2? Can't do it. Cube root of x cubed? I lost that cube, didn't I? Yep. So I have 3x square root, cube root of 2. Don't lose your index, please. Okay? So there it is, 3x cube roots of 2. Getting the hang of this? Yeah. All right, so go ahead and try C. Why don't you try C, D, and E, and we'll go over them. All right, square root of 243. Hold your horses. Oh, geez. I better unfreeze that. Okay. Square root of 243 divided by square root of 27. Square root of 9, right? What's the square root of 9? Plus or minus 3. Any problems with that one? Good. Next one down. Square root of 12x to the 4th divided by square root of 3x. Good. Square root of 4x cubed. What's the only thing I have to break down here? That x cubed. How am I going to change it? Now, I don't have to write it in different radicals. I can keep it all under the same one. It's the same exact thing. It's just how you prefer it. What's the square root of 4? What's the square root of x squared? You take the square root of just x, so you leave that. 2x squared of x. Okay. 9 times out of 10, you're just going to use the principal root, unless you're solving radical equations, which we'll talk about after. Okay. Did you do the last one yet? Almost. You need another minute? All right, so how many of you are thrown off by that index of 4? Yeah. Okay, so we need to know what our perfect 4th roots are, right? We know our square roots, we know our cube roots, we need our 4th roots. So I know the first one is 1. What's 2 to the 4th? 16. What's 3 to the 4th? 81. What's 4 to the 4th? 256? 625. That's good enough, right? So those are your perfect fourth roots. Okay. Now, we're going to start with the division piece. So, what's 1,024 divided by 4? 56. Oh, that makes it easy, doesn't it? What's x to the 15th divided by x? Good. So I know right now that the fourth root of 256 is what? 4. So I can automatically take that out. No, I only need to deal with that piece. Okay, so I need the largest number that 4 will divide into that's less than 14. 12. Yeah, so we're going to do fourth root of x to the 12 and fourth root of x to the second power, right? Are we okay with that? Right. So what's the fourth root of x to the 12? 4x cubed. Good. And can I do anything with this? So you leave it. And there's your answer. What do you think? It's not that bad, right? Yes, dear. Yeah, really for these purposes, you're just going to use the positive. More so when we're doing the plus and minuses when we're solving equations, which we're going to get to like the next 2 lessons. Okay? Good question, though. Okay, now, I'm not going to go any further with this, obviously. So your homework is to redo your homework from last night now that you can actually do it, correct? Okay, so your homework for tomorrow is going to be pages 3 and 4. We'll finish this lesson tomorrow. You'll probably have time to finish it right in class. Okay?